Hi, good morning everyone. I am Sivagami Priya, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science. Now I am going to handling subject TOC, Theory of Computation. Shall we move to the subject? Okay, the first one, what is meant by computation? Computation is nothing but it is a process of calculating something, that is called computation. The next one, why we are using computation, then where we are using computation. Shall we move? Okay, the first one, why we are using computation. And the first one, speed, accuracy. Okay, then we can reduce the human error problems, solving complex problems. Then you can innovating technology. So that purpose we are using computation method. Okay, where we are using computation, where we are using, there are many fields we are using computation method. Okay, the first field computer and software engineering, the next one artificial intelligence, the third one bioinformatics, then finance and banking. Okay, computer science and software engineering running the application. While we are running the application, that time we can use computation. Then a spreadsheet like a excel sheet, then science and engineering. Okay, simulating weather patterns. Okay, next one AI, artificial intelligence, chatbots like a YouTube, Netflix, so many applications. Then finance and banking, calculating interest rates or loan. Okay, then stock market, many fields we are using computation method. Okay, the first one, finite automata in theory of computation. Finite automata are a fundamental concept of theory of computation. Okay, essential for grasping various computational models. Their significant spans diverse applications, including pattern recognition and compiler design, underscoring of their vital role in the field of computation. Okay, the next one, basics of finite automata. Okay, automata means are abstract machines that can be in a one of a finite number of states. Okay, the machine only denotes finite number of states at any given time. Okay, then they process input strings from the one state to, we can give the one input, then it will process to the next state. That is called finite automata. Next one, types of finite automata. There are two types of finite automatas are there. The first one DFA, the next one NFA. DFA expansion, deterministic finite automata. The next one non-deterministic finite automata. DFA have a single state transition method for each input symbol. In DFA, only one input symbol have only one state transition, but NFA have a multiple transition for single input. Okay, that is called NFA. Then components of a finite automata. The components of finite automata, it will consist a set of state, input alphabet, a transition function, then starting stage, final state. These are called components of a finite automata. Okay, next one, applications in compiler design. There are many applications in compiler design. The first one, lexical analysis. Lexical analysis, it is nothing but it is a finite automata or used to tokenized identifiers, keywords. There are many types in lexical analyzer. Regular expression. Okay, these are called lexical analyzer. The second one, regular expressions. Regular expression, it is converted to finite automata, then finite automata convert to regular expression. Okay, this is the main purpose, pattern recognition. Okay, the third application is syntax checking. Okay, whether it is true or false, we can check like that. That is called syntax checking. Integrated finite automata with parsing techniques ensures code structure adheres to define the grammar. Fourth application, text searching. Finite automata are widely used in algorithm for text searching, enabling efficient multi-pattern searching. Whenever we are giving one text, It is widely used algorithm for text searching. That is called text searching. Next one, image processing. Next application, shall we see? Image processing. In image recognition, finite automata identify patterns and features aiding in computer vision. Okay, the next one, speech recognition. Finite automata help a spoken language by recognizing phonetic patterns. There are, did you know the phonetic? Each letter have a different, each alphabet have a different sound. That is called phonetic patterns. Okay, the speech recognition system. Next one, understanding network protocols. Okay, protocol is nothing but it is a set of rules and regulation. That is called protocol. Finite automata are used to model network protocols, providing a formal way to describe the states and transitions that occur during communication between devices. Whenever we sending the message from the client to server, that time we can using protocols. Okay, communication protocol, that is called communication protocol. The next application, error detection. In this error detection, we are using finite automata protocols can be designed to detect error. Whenever we can find out the errors, that time we can detect the errors in data transmission, ensuring that information is accurately sent and received. We have to check particularly the message will send or not, that time. That is called error detection. Next application, state synchronization. Finite automata help in maintaining state synchronization in distributed system, ensuring that different parts of a network remain coordinated. Next one, game development. Game development. The main purpose we are using computational method in game development. Example, artificial intelligence. Finite automata can be used to create a non-player character behavior in games. The next one, event handling. Event handling. Event handling. A finite automata can be handled various events and state within game engines. Okay. Same like that animation control also. Then limitations of finite automata. There are some limitations of FA, finite automata. The first one, computational power, then memory constraints, then scalability issues. Okay, the first one, computational power means the recognize regular languages and cannot handle context-free languages. Memory constraints, they can struggle with tasks that require memory or stack operations. Scalability issues. As the complexity of the language grows, the size of the finite automata can increase significant.